Okay, so the goal now is to be able to do a QTL analysis of rosette leaf number, which you already have.
Mhm.
So that's what I'm working towards right now. That's the prize. And so what I did since last time is I simplified this R script and tried to make it more general so that you can just add in the rosette leaf number data and you can update it. So I think a lot of the stuff we discussed last time would be helpful here, but it's going to be different.
Okay.
So just to go through it, first thing, of course, set the working directory. Make sure that you have all those 3 files I sent to you in the same folder, and make sure that this R script is also in that folder. And then you can just set the you can set the working directory to the source file location, and then make sure you've got these packages installed. I don't think that I do. So I think I probably have to install them. So I'm just going to go ahead and install them, because I updated to a new version of R, so it wipes out all of my libraries. Okay, this one looks like that there's some dependencies that are already installed for it. It's freaking out. When it freaks out when you're doing install packages and it says you already have this package installed or you already have dependencies installed, just tell it no, 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 0, none, no, no.
Okay.
Calm it down. You don't want to do any changes. You want to do 0 new additions. You don't want to restart R. So I'm going to tell it no. Okay, finished. Okay, and then that one. Good. All right, now I'm going to load those libraries. Okay. I have this set up to save everything out to a PDF file. For now, I'm going to skip line 19, but normally we would want to run line 19. Normally, when you have everything set up properly, you can run lines 18 through 125 altogether. But let's talk about how it's set up. First thing is you need this genotype file that we talked about last time. Let's go ahead and take a quick look at it. And this genotype file isn't something that normally that you would make. This would be something that whoever designed the recombinant inbred line package would make.
Right.
So here in this column, these are the names of the recombinant inbred lines, in our case, epirils, but this would work with any recombinant inbred lines. Just make sure that your names of the epirils are consistent across all of your files, right? So if it's called epiril 8 in one of your files, make sure that in another one of your files, it's also called epiril 8, and it's not just called 8, because then R won't recognize that it's the same individual. Right. Okay. And then this row here tells what chromosome, these columns are your markers. This row tells R what chromosome the markers are on. This row tells R what the relative map position of the markers are in centimorgans. Recombination distances, recombination-based distances. And then they're at each marker, they're either an A or a B. I forget which one is methylated and which one's unmethylated.
I thought we said A was unmethylated.
Okay, so let's just go with that for now.
Yeah. I have it written down if it's wrong.
Right. So this may be the reverse, but we think that it's A is unmethylated and B is methylated. So that's the data there. So that's just the genotype data, and the map data is together in that one file. And so that is going to be so we're creating this R object using this read cross command from the QTL package, where it's going to read in that genotypes file along with the phenotypes file. So let's talk about that phenotypes file. So this is the way that you should have it set up. The first columns should be your phenotypes. So here we've got flowering time, and the names of these phenotypes, you could call them anything you like. But so the first row has the names of the columns. So we have the flowering date from your data. That's that phenotype. Here for these same epireals, we have the flowering date from the QTL data. And then in this third column, we have the names of the epireals. Just be careful so what we would do here is, if we were going to use rosette leaf number, we'd add in another column. Or like here at the beginning, we'd add in another column for rosette leaf number. But just be careful that when you do that, look at the data's not in the same order here. You see how it's all like in a different order? It starts with epireal 101.
I got a question.
Yeah.
How did we get the decimal points if it's flowering date?
Good question, because it's the average of the flowering date among the replicates.
Right, yes.
So just be careful when you enter in the rosette leaf number column. Like, one thing you could do is we could sort by ID. We could do data sort. We could sort by ID. Well, it looks like it is sorted by ID. Just make sure that your other spreadsheet where you're pasting in the rosette leaf number data, that you have it sorted in the same way. So that just as, row 4 on here is epireal 11, make sure that row 4 and the other phenotype data you're pasting in also, that it matches up.
Okay.
But that's the basic idea. This is the format. The last column will have the epireal IDs, or the recombinant inbred line IDs. Then any other columns that you add, you just put them in before that. So for instance, I could do, on a Mac, I'd push down on the trackpad with 2 fingers, and I would go insert, and it'll insert a new column. And then that's where I would put in the new column of data. And I'd be sure to give it a title like rosette leaf or something, whatever. So that's how the phenotype data is set up. And then just leave everything else the same. So that's how you would have that set up. Then here, we're removing the outliers. These are data values that are so extreme that they would throw off all the statistics. So like if let's say a particular strain, everybody flowers by about
Day 35 and one does that day 2 or day 3, whatever.
right, or day 200, then just this script will remove them. But here's the important thing. You'll have to modify the script based upon how many phenotypes you have. So let's go back here. In this script, which is, it's set up for 2 phenotypes. So in column 1, we have a phenotype, and in column 2, we have a phenotype. If we added another phenotype here, then we would have phenotypes in columns 1, 2, and 3. So keep that in mind. So the way it's set up right now, first, this chunk of code removes the outliers for the first phenotype. Then this chunk of code here removes outliers for the second phenotype, column 2.
Right, okay.
Now, if there was a third phenotype,
It would be the same thing, but with the 3.
and you'll have to modify it. So you'd have to copy all of that, come down here, add it in, and then
Mhm.
there are 1, 2, 3 places here to change it. And then down here, there's again another 1, 2, 3 places to change it. So like that for how many phenotype, for however many phenotype columns you have. Of course, for the example right now, we only have,
The one without the number.
we just have, no, right now I'm just showing you using your flowering time data versus Cortillo's flowering time data with like just flowering date. Oh, it's telling me I didn't install all the libraries. Oh, I see. That's an old warning because I did install all the libraries. I mean, I did load all the libraries. Yeah, they're all there. Okay. So then you would run this line here. And I don't understand exactly what it's doing, to be honest, but this is what I read online that you're supposed to do next. Is you're supposed to use the hidden Markov model to calculate the probabilities of the true underlying genotypes, giving the observed multi-point marker data with possible allowance for genotyping errors. So this is a data processing step you would do once you've got everything in order. You would run this data processing step on your data. There's nothing to change here. No matter how many phenotypes you have, this will be the same. Same thing here. Okay, we're going to look. Okay, so the first thing here. So let me run some of these lines of code. Again, normally we would just run lines 18 through 125 altogether, but I'm going to skip line 19 because I don't want to write this to a PDF file for now. So I'm just going to run line 22. I'm going to get rid of the outliers. I'm going to run that data cleaning step. Now we're going to look at our phenotype names. So there's our phenotype names. So the important thing here is, again, remember how many columns of phenotype data you have. We have phenotype data now in columns 1 and 2. So that's important here. We're creating this R object of the names of our phenotypes. We would adjust this here based upon the columns that have our phenotype data. So if we had 3 columns of phenotype data, instead of this saying 1 to 2, this would say 1 to 3. And you can check yourself here to see how many columns have phenotype data and just adjust this trailing number here accordingly. But in our case, we just have the 2 columns. So we leave this as is, run it. Okay, now this command here actually runs the QTL analysis. And it's going to run the QTL analysis on on each phenotype individually. It knows to cycle through the phenotypes. It's using the scan1 function of the QTL package. So it's going to be running that. So this command will run the scan1 function on our R object QTL file. We're telling it which columns are the phenotypes, and we're telling it to use the Haley knot regression method. So let's do it. Okay. Next, we have to do a permutation analysis on the same data to get our significance thresholds, those dotted lines that appear on the graph. So that's what this column row does. And it takes a little while. I think we have it set up for 1,000 permutations. Okay. All right. Now we're going to look at the results. So this R object here I call calls, but you could call it standing for colors. but you could call it anything. And this R object will contain the colors that we want to use to display our results. So we only have two sets of results. We have the results in here from your flowering time data versus QTL. If we added also in your rosette leaf number data, then we would have three. But right now there's only two, so you'd have those two. So there's two colors. You're telling it what color to use for each set of results. Now, if we did have a third column of data, we would need to come here, do comma, and then come up with the color that we would want the third one to be. So we could call it black. We could make it black, or we could make it green, whatever.
Right.
Just understand that this row here will need to be modified according to how many phenotype columns you have. All right, but since we're just working with the default right now, we'll just run it as is. Okay, now we can plot our results. There's nothing. Oh, here we are. So then this is going to plot our results. You do not need to alter this numbers here. You do not need to alter these numbers, even if you had 100 phenotypes. This is referring to something else. So you don't have to make any modifications here. You just plot it, no matter how many phenotypes you have. Keep this as 1 to 2 right here. And there's the familiar, not cleaned up in Inkscape, but there's the familiar QTL results graph. Doesn't have, now notice it doesn't have the permutation thresholds yet. So that we have to add. And what here you would add another line of code for every column of phenotype data you have. So right now we only have the two columns 1 and 2 of phenotype data. But let's say we had a third column of phenotype data. We could take this here, copy it, put it down here. And what we would change is we would change this to be 3 for the third column of phenotype data. And then we would change this color here to whatever color you chose for that column of phenotype data, black, green, blue, whatever. So that's another thing to keep in mind. That's another thing you would need to alter for this script. All right, next, okay, so now this line of code here will pull out the markers that were significant for each of the phenotypes. It's not going to pull out the QTL intervals yet. Right now, it's just going to pull out the like the actual markers that were significant. And then later in the script, it will actually pull out the entire intervals, the 95% confidence intervals.
Right.
But anyway, you don't have to modify anything here, no matter what. You can just highlight it and run it. Oh, okay. So this shows us the significant QTLs. So anyway, there they are. Okay, we can look at them, but we need to save that out. Oh no, now we're going to get the QTL intervals. So lines 88 through 91. Again, nothing to change here. You can always just highlight it and run. Doesn't matter how many phenotypes you have. Okay. And then this is like a data cleanup step that I don't understand, that I got this from online, but this is a part of the data cleanup. You run that. Okay. Now this is continuing to try to get us those confidence intervals. So we're going to highlight lines 97 through 108, and we're going to run it. Okay, and then I have it set up to print out the results so we can see. So here is all the data. Here's our QTLs. So we have a significant marker for your data. We have a significant marker on chromosome 1 at position 4.1. And the 95% confidence interval for that position, wait. .1, sorry. The 95% confidence interval for that position, so the point estimate is that significant marker was at 41.1. The 95% confidence interval for that position is in between 18 and 63. So that's our so anyway, that's just to show that it worked. Now we're going to write that out to a file. And now we're going to plot on, we're going to do that second plot where it's going to show the QTL intervals next to the chromosomes. It's like figure 2 on your poster or something.
Oh, okay, yeah.
You'll see here in a second. Now, before we do, I have to give you that caveat again that you'll have to update this script. If you have 3 phenotypes, you'd have to come in here, do comma, and then whatever that third color is, green or whatever, you'd have to come in and add that. But in our case, we're just doing the sample data, so we just have the 2, so you just leave it alone. So now we'll just highlight that and we'll run it. And there you go. There you can see the familiar thing that you worked on a lot. And there you have it. And that should, so if as long as you make those modifications, it should scale up quite nicely with the number of phenotypes. But again, if you do have everything set up right, well, then when you run it, so you could do what we just did here, which is try running just the little chunks. But then when you're sure that you've got everything working, then what you would want to do is actually run lines 18 through 125. When you do that, it won't put the plots on your screen. It'll just save them out to the PDF file. So let's just do that real fast and make sure that that works okay. Okay, so it looks like everything worked. Now we're going to look at that PDF file and just make sure that it actually output the results. And there it is. And if we had 3 phenotypes, you'd see 3 colors on here. You'd see 3 significance thresholds, 3 sets of lines. So now here's what I'd like you to do for your homework. I'd like you to come in here. Oh, and also notice that the way that I have the script set up, when you're missing data, you just put in capital N, capital A, not applicable. And then that's the way it knows to read that in as missing data. But anyway, what I'd like you to do is to add to the to that file, QTL file _pheno.csv. I want you to open it up, add another column, call it rosette leaf number, whatever, and I want you to add in fake data. Whatever, just put in some nonsense. Fill it out, save it. And then, given that you now have 3 columns, just see if you can get the script to work and to show you 3 sets of results. Okay. Now, of course, that first set of results containing your nonsense will be nonsense results. Right. But let's see how it works. Yes, sir. Okay, and let me. You can send me this whenever you. Yes.